Hey, if you checked out our previous explainers, this is going to be a nice little summary that helps tie it all together into one cohesive picture. Today, we're taking the theoretical framework of durable engineering and we're just crashing it right into the gritty reality of a real-world case study. We're going to see what actually happens when an industry expert, a totally serious veteran software developer, and an AI all try to build a custom system together. All right, let's fly through our roadmap for today. First, the modern collaboration trap. Then, the durable engineering fix. Next, our case study on the asymmetric team, followed by fixing the artifact mismatch, and finally, the next era of builders.
So let me introduce you to the hero of our story. This quote from the source material is literally the perfect description of a modern small business owner. He's been running an agency for 5 years, right? He knows his industry absolutely cold, but he only has surface level coding skills. He isn't some master programmer. He's the exact guy who knows just enough to get himself in trouble. And if you've ever tried to piece together a bit of custom software for your own job, you are probably this person.
Okay, section 1, the modern collaboration trap, navigating the zoo of dysfunctions. Let's start with why our standard workloads are so fundamentally broken. Our cardinal sin in teamwork actually has a name. It's called relitigation. We have this terrible, terrible habit of treating our brains like persistent storage. Like a giant computer hard drive. But they don't work like that. Human memory actually functions way more like volatile RAM. The absolute second a project pauses, our context starts to decay. If you don't write down exactly why you made a specific decision, your team is inevitably going to have to make that exact same decision again 3 months later. It is a completely invisible, massive drain on your team's energy. And here's the thing about a typical 30-minute synchronous meeting. It's not actually about rigorous analysis. It's almost entirely about vibes and consensus. Think about it. A 4-person, 30-minute meeting is literally 2 collective hours of human life lost. People nod, everyone generically agrees the new feature should be scalable, and you walk out with this total illusion of a plan. Asynchronous writing, on the other hand, functions as a literal lie detector test for your own brain. The second you try to type out exactly how something should be scalable in a document, you hit a massive wall if your logic actually has gaps. Moving on to section 2, the durable engineering fix, converting coordination into artifacts. So how do we actually fix this? How do we protect our focus time and minimize those really dangerous, messy handoffs between teammates? Well, the answer is creating durable artifacts. But listen, you do not need some massive bloated company wiki. You basically just need an arsenal of 4 critical artifacts to build a real async-first culture. You need architecture decision records, or ADRs, just simple one-page docs explaining why a choice was made. You need detailed pull requests for code handoffs. You need blameless postmortems so you can learn from failures without, pointing fingers. And you need step-by-step runbooks for your recurring tasks. That's it. Less is definitely more here. Now, if you're building software together, this specific artifact is your absolute ultimate blueprint, the module contract. Think of this like a carpenter and a plumber working on a new house. If they agree in writing on the exact 1-inch coordinates on the wall where the pipe is going to meet the cabinet, and they do this before they build anything, they are never going to collide. The module contract explicitly defines what your code will do and what my code will do. All right, let's dive into section 3, case study, the asymmetric team, checking out the strong boss case file. Let's see how all this theory actually plays out. Check out this timeline tracing our agency owner's 5-year journey to finally get custom software leverage for his business. It perfectly mirrors the exact path tens of millions of small business owners are on right now. Year 1, he's just running the whole show on spreadsheets. Year 2, he's kind of vibe coding little tools with early AI. Year 3, he tries to hand code it himself but hits a total wall. Year 4, he tries hiring freelancers, and they just ghost him. Finally, in year 5, he pairs advanced AI tools with a credentialed, highly serious development partner. And wow, what a fascinating team they make. We're looking at radical asymmetric tooling here. On the left, our domain expert is completely AI forward. He thinks in high-level concepts and just lets the AI write all the code. On the right, his partner is a serious veteran developer who strictly hand codes in C and PHP and totally refuses to use AI. But here is the most brilliant part of this whole setup. The serious partner actually forces the drawable engineering model onto the entire project because he flatly refuses to take synchronous voice or video calls. They can literally only communicate through asynchronous text. But wait, it wasn't instantly smooth sailing. Actually, they hit that cardinal sin of relitigation right out of the gate with a brutal 4-hour text argument. The partner looked at the AI-generated architecture the owner sent over and basically asked, what do you even need me for? I would build this totally differently. Which brings us right into Section 4, Fixing the Artifact Mismatch, Uncovering the Real Bottleneck. So, a specialized coach steps in to audit their workflow and discovers something wild. The agency owner was writing what he honestly thought were architecture documents for his human partner, but they were unintentionally hostile. There were these massive 45-row instruction checklists written imperatively for an AI model, and the poor human partner was just politely CC'd on them. This right here perfectly illustrates the core bottleneck of their whole project: context transfer rate. See, writing for an AI model is essentially like taking an open book exam. You can dump thousands of lines of context into the prompt, and the AI just instantly absorbs the whole shebang. But writing for a human, that's a closed book exam. Humans have a very real flooding threshold. The partner was just getting completely slammed with an absolute tidal wave of AI context, and it was causing immense friction. So, the crucial takeaway here is that they didn't need to fundamentally fix their communication skills. They weren't in need of couples therapy, right? They just needed a completely mechanical fix for their artifacts. The new rule was simple: answer what is true before telling someone what to do. Write short documents to carefully meter out the context delivery to the human brain. Once they fixed the format of the document, the friction in the relationship completely vanished. Okay, prepare to have your mind blown for a second. There is an incredible meta layer to this whole case study. The diagnostic workbook that the coach used and the super well-structured handoff packages detailing these exact practices, they were themselves generated by an AI team. The AI agents were actually practicing the durable engineering field guide with each other in order to teach the humans how to do it. It is just a completely wild look at our future synthetic workforce. And finally, Section 5, the next era of builders, dissolving the lines. So, what does this all mean for you? Well, we are entering the new normal. It used to be that everyone on a software team had to use the exact same tools and the exact same text editors. Not anymore. We are moving away from tool consensus and toward interface consensus. As long as your code meets that module contract at the boundary line, your partner shouldn't care if an AI wrote it or if you hand-typed it yourself. And because of this, the lines between a highly technical software engineering team and a regular, everyday small business are completely dissolving. But hold on, quick reality check. The source material hits us with this fantastic reminder. The tool gets you across the river, but you still have to walk. Leveraging this incredible asymmetric AI power is not a magic push-button solution. It still absolutely requires genuine cognitive labor. You still have to do the rigorous, hard work of writing down your module contracts, defining your variables, and really respecting the limits of human focus. Leaving you with this final thought today: the very next time you find yourself working and thinking, man, I really wish a tool existed for this, don't just immediately go look for a new monthly subscription to buy. Stop and ask yourself, do you know your business well enough to describe the tool you want at a pseudocode level? Because if you have that deep domain knowledge, just one single trusted collaborator, and a solid set of durable artifacts, you basically hold the entire hand to build exactly what you need. Pretty exciting stuff to think about.
And I just want to give a special shout out to my birthday bro, the arm, the head. You know who you are. I wish I had more friends like you, and thanks for inspiring and encouraging me. I've always been glad to know you. Now let's continue the self-psyop, haha.
Oh man, that is quite the kickoff.
Yeah, I mean, you know I had to get that in there before we do anything else, but jumping right in today, imagine you walk into a room, right, and you realize two highly skilled professionals have just spent 4 grueling hours locked in this incredibly tense argument.
4 hours? That sounds exhausting.
Right. It is. And the crazy thing is, they aren't debating equity, and they aren't arguing over the project budget or anything like that.
Well, that's the issue.
The entire breakdown stems from a single project document. It was intended to be this, helpful primer document, but it actually read like a hostile imperative command issued to a robot.
Oh wow, yeah, that'll do it.
Exactly. And that is the reality of trying to merge human engineering discipline with artificial intelligence in real time. We are looking at a collaborative landscape today that is just fundamentally asymmetric. And the friction it creates is staggering.
It really is. I mean, the old rules of synchronization assume a level playing field, you know. They assume everyone is using similar tools, speaking the exact same dialect of code, and moving at a relatively similar velocity.
Which is definitely not what happens when AI gets involved.
Not at all. When you introduce a large language model into that environment, acting as this ultra-fast but highly volatile junior developer, the traditional assembly line just shatters completely. The structural mismatch becomes the defining challenge of the entire project.
And that structural mismatch is the mission of our deep dive today.
Hmm.
We are examining what happens when a domain expert, so a small business owner with deep industry knowledge but surface-level coding skills, pairs up with a veteran strict software engineer and an AI to build a custom production-ready application.
It's a fascinating dynamic.
It really is. And to guide us through this, we have an exceptional stack of sources today. We are parsing real-world in-flight coaching logs from an actual two-person team attempting this exact setup.
Real logs, that's incredible data.
Yeah, we're cross-referencing those logs with a Durable Engineering Field Guide, which details modern asymmetric team architecture. And we're also pulling insights from a build-pilled YouTube transcript that breaks down the mechanics of modern knowledge work dysfunction.
So we've got the theory, the mechanics, and the actual raw case study all in one place.
Exactly. Okay, let's unpack this. We're looking at an agency owner who runs an SEO and web services business dedicated to blue-collar contractors. You know, plumbers, roofers, HVAC companies.
Right, the kind of guy who knows his operational pipeline flawlessly.
Flawlessly. He can map out his entire business logic without even hesitating. But on the technical execution side, he describes himself as someone who, and this is a quote, can't hand code at an effective pace.
Ah, okay. So he knows what he wants, but he just can't physically type it out fast enough.
Right. He possesses just enough technical literacy in PHP and MySQL to be incredibly dangerous.
Yeah.
He's the exact guy who knows enough to get himself in trouble.
It is a very specific, very common profile right now.
Yeah, and he's attempting to build a highly customized CRM for his agency, which he calls Stronk BOS. BIOSAS, standing for Business Operating System. And to get this done, he brings on a highly credentialed senior engineering partner.
And let me guess, they hit a wall immediately.
Almost immediately. Just a brutal wall of interpersonal and technical friction. They are grinding gears at literally every phase of the project.
Well, to contextualize that friction, we really have to look at the baseline environment they're in. The coaching logs refer to the owner's situation as a forefront war of stacked transitions.
Stacked transitions.
Yeah, so he isn't just trying to write a piece of software. He is simultaneously trying to completely redesign his underlying business operations. He's learning how to deeply integrate an LLM into his daily workflows. He's navigating a brand new collaborative dynamic with a senior developer. And on top of all that, he is attempting to rewrite his own executive role within his company.
Man, any single one of those transitions requires a massive cognitive load.
Exactly. Stacking 4 of them concurrently pretty much guarantees organizational chaos.
And the asymmetry between the two collaborators is totally the catalyst for that chaos. So let's look at the players. The owner is deeply reliant on AI. He basically uses Claude as his primary integrated development environment.
Right, he's not in VS Code typing out brackets.
No, his workflow revolves entirely around vibe coding. He writes broad pseudocode, establishes heavy scaffolding, and just lets the model generate the actual syntax. He acts as an aggressive editor of AI output rather than a traditional author of code.
Which is incredibly fast, but also very messy. And then you look at the partner. He brings nearly 2 decades of serious engineering experience in languages like C, C++ Lev, and robust PHP.
So he's the real deal.
Absolute real deal. He spots architectural inconsistencies instantly. His methodology requires building and verifying one careful mechanism at a time. But the most critical detail regarding the partner's methodology is his communication stance.
Oh, right. This drove me crazy reading the logs.
He is strictly asynchronous, he flat out refuses voice calls, and he categorically rejects video syncs.
Which creates an immediate collision. The logs detail this moment where the partner reviews the heavily AI-augmented code base the owner generated. He looks at the architecture and explicitly asks, "What do you need me for? I'd build it differently."
And that single question just sets everything off.
It precipitates a massive 4-hour discussion between them. And, I want to push back on the partner's stance here on behalf of anyone listening. If you hit a fundamental architectural disagreement with a collaborator, insisting on asynchronous text communication seems incredibly counterproductive.
You think they should just talk it out?
Yeah. Sometimes getting into a room or just hopping on a quick Zoom call and hashboarding the problem out for 20 minutes is the most efficient way to break a deadlock. Refusing to speak verbally just feels like stubbornness disguised as discipline.
I get that. Culturally, we are deeply conditioned to believe that verbal synchronization is faster. We just think, let's jump on a call and clear this up. But the build-pilled analysis actually dissects that exact 4-hour marathon meeting.
And what do they say about it?
They categorize it as a textbook sync disaster. It is literally referred to as the phantom menace of knowledge work for a very specific mechanical reason.
The phantom menace. That's a great term.
Right, because think about the cost. A 4-hour meeting between two senior people vaporizes 8 hours of collective, highly paid human focus. Furthermore, what actually occurs in those unstructured marathon syncs is rarely rigorous architectural analysis.
So what is it then? Just arguing?
Mostly, the rigorous analysis is replaced by the illusion of consensus. People sit in the meeting, they nod along to broad, agreeable statements like, we need to ensure this module is scalable.
Oh, yeah. Everyone loves scalable.
Exactly. And their brains register a dopamine hit of productivity. They feel aligned. But they haven't actually made a concrete engineering decision. They have merely agreed on the vibe of a plan.
Ah, I see. Because nobody was forced to commit the exact specifics to a durable medium.
Precisely. So 2 weeks pass, a technical constraint emerges, and the team is forced into the absolute cardinal sin of software development.
Relitigation.
Relitigation. They end up having the exact same 4-hour argument all over again. So the partner's refusal to jump on a video call isn't just him being stubborn. It's a reflexive defense mechanism against this exact cycle.
Okay, that actually makes a lot of sense when you put it like that.
Yeah. By enforcing an async-first culture, he demands that the team rely on durable artifacts rather than the fallible, volatile nature of human memory. Forcing a collaborator to write a paragraph defending an architectural choice acts as a cognitive lie detector test.
A lie detector test, how so?
If there's a gap in the logic, the writer literally hits a wall mid-sentence. They can't finish the thought. You cannot vibe your way through a formal written proposal.
Wow. But the irony in this case study is that the owner actually did try to rely on written artifacts, and it just backfired spectacularly.
It really did.
Yeah, so since talking it out for 4 hours failed, the team brings in a specialized coach to audit their workflow and stop the bleeding. And the coach immediately examines the written documentation. This uncovers the first major structural failure, which the logs title the hostile artifact.
And what's fascinating here is the coach's audit reveals this incredible blind spot in how people transition into AI-assisted workflows. What did the owner actually produce in those documents?
Well, the owner believed he was drafting what he called primer documents to align with his human partner on system architecture. But the formatting was entirely alien.
Alien how?
The documents were structured as highly detailed imperative prompts aimed at a machine. One of the documents literally featured an introduction that read, in all caps, instructions for the human.
Oh man, instructions for the human.
Yes, and the only instruction was to politely upload the subsequent text file to the large language model. The remainder of the entire document was just this dense 45-row checklist of imperative commands.
Handing a senior engineer a 45-row machine prompt and calling it collaboration is just deeply alienating. It strips the human of their agency completely. It treats them as a simple API endpoint for an LLM.
It's the equivalent of writing a romantic anniversary card to your spouse, but formatting it as a Python script with nested loops. It just completely destroys the intent. You cannot hand your human partner a checklist addressed to a robot and expect them to feel invested in the architecture.
That's a perfect analogy. And the underlying coaching philosophy applied here is critical for modern management. The coach's motto is, don't fix people, fix artifacts.
Don't fix people, fix artifacts. I like that.
Yeah, the coach doesn't attempt to psychoanalyze the partner's frustration or conduct like trust fall team-building exercises. The partner was reacting entirely rationally to a document that was structurally hostile.
So the intervention was purely structural then?
Purely mechanical. The coach institutes a strict new formatting rule for all documentation. The rule is, answer what is true before what to do.
So establishing the shared reality first.
Exactly. Mechanically, that means before issuing a single task or command, the document must establish human-readable context. It has to outline the architectural principles at play, document the current state of the database schema, provide a clear change log, things like that.
It grounds the human reader in the actual reality of the system.
Right, because a veteran engineer can digest an architectural overview, spot constraints, and learn from a schema definition. Once that shared understanding of what is true is firmly established in the text, then the specific instructions or AI prompts for what to do can be appended.
Okay, so regulating the documentation format de-escalates the interpersonal tension. But a friendly document doesn't stop poorly optimized AI code from crashing a server, right?
No, it definitely doesn't.
So there was still a glaring technical mismatch between the AI's output and the partner's engineering standards that needed addressing, which leads the coach to the second major intervention, validating instincts and establishing the module contract.
Right, because earlier in the development cycle, the human partner had flagged a severe architectural anti-pattern in the AI-generated code.
This part was wild. The LLM had written a script that was querying an entire relational database table, completely bypassing server-side indexing and pagination, and shipping that massive data payload directly into the browser's local JSON memory.
Just so the end user could filter the results on the client side.
Yeah. To anyone familiar with scalable architecture, the mechanics of that are terrifying. Fetching a full table into client-side memory works flawlessly when you have 50 records. But the moment that application scales to 50,000 records...
You are totally choking the database's network pipeline.
Exactly.
Yeah.
You're completely freezing the user's browser under the weight of a massive memory footprint. The partner correctly identified this as a catastrophic bottleneck, but the owner initially just dismissed it as a minor AI hallucination to be fixed later.
Right. But the coach's audit revealed this anti-pattern was actually deeply embedded across 5 different modules. It wasn't just a one-off.
5 instances. So how does the coach fix that without making the owner feel attacked?
The coach leverages this discovery brilliantly. Instead of just fixing the code, the coach points the human partner directly to the 5 specific file lines containing the anti-pattern.
Ah, I see.
Yeah, it serves a dual purpose. First, it explicitly validates the partner's engineering instincts. It proves that the owner's high-speed AI generation desperately requires the partner's rigorous architectural oversight.
Right, it gives him a real purpose in the workflow.
Exactly. Second, it carves out highly concrete, bounded work that aligns perfectly with the partner's skill set. The partner transitions from feeling like a janitor who just cleans up erratic AI output to operating as the critical architectural conscience of the platform.
But wait, when you have 2 drastically different development approaches, I mean, you've got one guy generating massive blocks of AI boilerplate in minutes, and another guy meticulously hand-coding optimizations in C++, you can't just mash those code bases together without constant merge conflicts, can you?
No, you really can't. And that's where the Durable Engineering Guide points to a very specific architectural defense mechanism, the module contract.
The module contract.
Yes. Module contracts are the definitive solution for asymmetric tooling. In this architecture, you abandon the idea of a tightly coupled monolith. The application is divided into strictly isolated service boundaries.
Okay, so breaking it into chunks.
Right. The module contract is the explicit, mathematically precise agreement of what happens at the boundary where 2 services interact. It defines the exact shape, type, and structure of the data payload going into a service and the exact payload coming out.
And the ultimate enforcer of that contract is the database schema itself.
Right, exactly. The structure of the tables, the foreign keys, the data types, that becomes the absolute unyielding source of truth for the entire team.
The implications of that are profound for collaboration. As long as the interface boundary is strictly honored, meaning the data leaving your module perfectly matches the schema, my module expects to receive the internal implementation of your module is entirely irrelevant to me.
Exactly. Interface consensus matters entirely more than tool consensus.
So the owner can use Claude to vibe code the internal logic of his module in 15 minutes. And the partner can spend 4 days meticulously handcrafting the memory allocation for his module in C++ Maya.
And because the boundary contract is rock solid, the asymmetric tooling doesn't break the system.
That's amazing. You are completely liberated from arguing over how the work is done because the only thing that impacts the system is what is delivered at the boundary.
It's totally liberating. Defining those strict boundaries isolates the code perfectly. But isolating the mental load of the collaborators requires solving a much deeper, almost invisible friction.
Right, which brings us to the third finding.
Yeah, even with clear contracts and polite documents, the coach identified a critical failure in how the team was passing information back and forth.
The context transfer rate. The friction here stems from how the owner's daily interaction with an LLM had fundamentally rewired his communication habits.
It's a huge shift in behavior.
Here's where it gets really interesting. The best way to visualize this mechanical difference is to look at the constraints of an open book versus a closed book exam.
Okay, I love this metaphor.
So an LLM operates as the ultimate open book environment. It possesses a massive context window. You can dump 100 pages of unstructured documentation, disorganized notes, and sprawling system architecture into the prompt, and the machine absorbs it instantly.
Right, it doesn't suffer from cognitive fatigue.
Exactly. And the machine's capacity to process unstructured data trains the user to be highly verbose. The owner had developed these incredible open book muscles, but a human engineer operates under the strict constraints of a closed book exam.
Yeah, human working memory isn't a persistent hard drive. It functions much more like volatile RAM.
Yes. When an engineer is in this state of deep focus, diagnosing a complex architecture, they are holding a highly delicate, interconnected web of logic trees, variables, and constraints in their active working memory.
And when you take an engineer in that state and dump an unlimited, unedited block of context onto them, you trigger an immediate cognitive tax. The recipient pays the price of your verbosity.
The recipient pays. That is such a crucial concept.
A human brain just cannot simultaneously parse a sprawling 45-row instruction set while also holding the intricate state of a database schema in working memory. The cognitive load exceeds their volatile RAM capacity, and they essentially crash. They lose the thread of the architecture.
So the marathon arguments, the frustration over the documents, the friction over the AI code, these are all downstream symptoms of a mismatched context transfer rate.
Exactly. The owner was just overwhelming the partner's working memory.
So to cure this, the coach implements a ruthless metering of context delivery. The rule becomes explicitly meter your context. Do not dump everything you know about a feature into a single document.
Right. Instead, force one specific decision at a time and say only the smallest true thing needed to take the exact next step.
Short, targeted payloads of information.
Saying the smallest true thing needed to advance the logic protects the collaborator's working memory. It is a fundamental respect for human cognitive limits.
So what does this all mean? Zooming out from the granular mechanics of this specific coaching engagement, the broader implications of this case study are just staggering to me.
Oh, absolutely. The owner's 5-year trajectory is not an isolated anecdote at all. It maps exactly to the trajectory that millions of domain experts are currently navigating out in the real world.
Yeah, think about it. This owner started by managing his business logic on sticky notes and complex spreadsheets. Then he evolved into vibe coding rudimentary scripts that barely held together.
Then he hit a severe technical wall trying to build scalable systems himself. He experienced the frustration of unreliable freelance marketplaces like Upwork.
And finally, he arrived at the frontier, pairing a highly capable LLM with a strict, asynchronous human engineer.
And that specific configuration of talent and tooling represents a massive shift in economic leverage. Historically, if a domain expert, whether they run a regional logistics hub, a specialized dental network, or a blue-collar marketing agency identified a highly specific operational bottleneck, they had two bad options.
What were they?
Well, they could wait for a massive SaaS company to build a bloated tool that only partially addressed their niche. Or they could attempt to raise millions of dollars to hire a full engineering department to build it from scratch.
But the rules of gravity have fundamentally changed now. With deep, granular knowledge of your specific industry problem, a single highly disciplined collaborator to hold the architectural boundary, and a large language model to generate the syntax, you basically have the whole hand.
You really do.
You no longer have to wait for a SaaS company. The barrier to entry for creating production-ready software has completely collapsed. The line separating a small business owner from an engineering team has entirely dissolved.
And this new physics of building raises a fascinating, perhaps existential question for the technology sector at large.
Oh, what's that?
If domain experts across the globe can leverage module contracts, durable artifacts, and AI-augmented coding to build hyper-customized, highly specific software for their own tiny niches, just like Strong BOS, what is the downstream impact on the software industry?
That is a great question.
Right. Are we witnessing the beginning of the end for giant one-size-fits-all SaaS monopolies? Will the future of enterprise software simply be millions of bespoke, quietly brilliant microsystems built by the exact people who use them every single day?
Wow. That is definitely something to think about. Thank you so much for joining us on this deep dive. We'll see you next time.